For some reason, I can't review fractions without using pizza as an example. Here we have a pizza where a portion of it is missing, and we're asked what fraction of the pizza is missing. Well, in order to know what fraction is missing, we need to cut the pizza into equal parts. So we would look at this and say, if we cut this into equal parts, then the whole pizza would have had 4 parts, right? And so that's going to be the denominator of our fraction. And then the numerator of the fraction is going to be the number of parts that are missing. So here we have 1 part missing. So 1/4 of this pizza is missing. But what if we had cut the pizza into 8 equal slices? So what if the cuts look like this? Now how many pieces are missing? Well, it looks like now we have 2 pieces missing, but it's still the same amount of pizza. So if the pizza is cut into 4 slices, then 1 slice is missing out of 4. And if the pizza is cut into 8 slices, then 2 slices out of 8 are missing. But we know it's the same amount of pizza. So in terms of mathematical language, 2/8 and 1/4 are equivalent fractions. And here's what that means. I can take 2/8 and write it as, well, 2 is already a prime number, so I'm going to leave that in the top. But in the bottom, or the denominator of the fraction, I'm going to factor this as 4 times 2. Now, I have a 2 in the numerator and a 2 in the denominator, and those can cancel each other out. But when I do this, remember that I really have an invisible 1 sitting here. And so when I cancel those 2's, I'm going to end up with 1/4, which is the other fraction. Okay, so 2/8 and 1/4 are equivalent. We say that 2 fractions are equivalent if they are the same when they're written in lowest terms. So what we just did was we reduced 2/8 to its lowest terms. Let's try reducing another fraction to its lowest terms. To reduce 84 over 108 to its lowest terms, the first thing that we need to do is start factoring it. Now it turns out that 84 and 108 are actually both divisible by 12. In fact, 84 is 12 times 7, and 108 is 12 times 9. Since I have a 12 in the numerator and the denominator, I can cancel those 2 out and reduce this fraction to 7 over 9. Now 7 is a prime number. So because 7 doesn't divide 9, we know that this is our final answer. Let's check our understanding. Here we're supposed to check whether the 2 fractions are equivalent. When we look at this first one, 2/3, that's already reduced because 2 and 3 are both prime numbers. So let's just take a look at the second one, 6 over 9. Well, we can write 6 as 2 times 3, and we can write 9 as 3 times 3. So now we have a 3 in the numerator and a 3 in the denominator, so we can cancel those 2, and we're left with 2/3, which is the other fraction that we had. So these 2 reduce to the same fraction, which means they are equivalent. Now let's look at the second pair. Starting with 26 over 16, let's think about how these factor. 26 can be written as 2 times 13, whereas 16 can be written as 2 times 8. So now we can cancel out the 2's, and we have 13 over 8. 13 is a prime number, so that can't be reduced anymore. Okay, so now let's look at the second fraction. We have 21 over 14. 21 can be written as 3 times 7, and 14 can be written as 2 times 7. So here, we can cancel the 2 7's, and we're left with 3/2. Now these fractions are both simplified, but they're different. So these are not equivalent fractions.